Hopefully you did the last challenge, which had you create a list of lambda expressions or method references to be used by the string transform method. These were either unary operators with a type argument of string or functions with two string type arguments. In this video, you'll learn how to do something similar using what are called convenience methods. These are default methods on some of the functional interfaces I've been covering in the last few videos. The consumer, predicate, and function interfaces all come with these methods, as does the comparator, which I'll also include here. I've created a new project called Chaining Lambdas for this video. I'll create a couple of local variables here. First a string, and second a function that has two string types called uCase. I'll set the string to Tim, and the function to a method reference, string : 2 uppercase. Then I'll print out the result of the apply method, passing it name. Let's see if it produces what it looks like it's going to produce. No surprises to see Tim printed out, all in uppercase. This function interface has two default methods. The first default method is called and then, which allows us to chain functions together. Let me add a lambda expression to demonstrate this. The second function, last name, appends my last name to the string. By chaining these functions using and then, the output of uCase becomes the input to last name. So both transformations are applied in sequence. I'll print out the result. Let's see if it does what I just said it will do. And there you go. You can see that Tim was capitalized and then Buchalka was concatenated. In addition to the and then method, this interface also has a compose method. I'll execute compose on the uCase function, again with last name as an argument, and print it out. So what exactly does compose do? The opposite of the and then method actually. With this code, it will execute the last name lambda first, then it will execute the function contained in uCase. I'll confirm that. You can see my full name in capital letters. For that to have occurred, my last name had to be concatenated first and the uppercase method reference applied after that. You can use either in the context of your code, which best fits the situation. The compose method is only available to lambda expressions that target either a function or a unary operator interface. Bifunction, binary operator, and other function category interfaces that take a primitive don't support the compose method. Keep in mind that your chained lambdas or method references don't have to return all the same types within the chain. Let me show you what I mean. I'll type this in, then explain it. In this code, the declared type arguments of the function are string as the input type and string array as the output type indicate that I expect the final result to be an array of strings. The functions are chained in such a way that the last one returns a string array, which matches the expected return type. This is the call to the split method. The first function, uCase, is a method reference that converts the input string to uppercase. The second function is a lambda that takes this uppercase string and appends Buchalka. The final function, another lambda, splits the string into an array of strings. Although each function returns different types, string for the first two and an array of strings for the last, the final result matches the declared return type string array of F0. I want to highlight that the intermediate functions in the chain don't need to return the same type as the final result. Each function just needs to produce a type that the next function can accept as input. Only the last function in the chain needs to return a value that matches the declared return type specified by the function. In this case, again, it's the split method. You can see the array printed in my output when I run this. Let's keep going. I'll copy those statements in the previous function variable above and paste them. I'll start with renaming the variable to F1 and then change the second argument from an array of string to just a string. After the lambda with the split method, I'll remove the semicolon and insert a new line. I'll chain another call to and then, passing a lambda that will take the second element of the array element, which is its input, making it uppercase. Then the expression adds a comma and the first element of the array. Finally, I'll print the result of the apply method on that chain of functions. What's different here and interesting is the input to this expression is an array of string with first name at index 0 and last name at index 1. IntelliJ, if you have hints turned on, is really helpful when you are chaining function lambda expressions like this. It will tell you what the inferred types of the interim expressions are. The lambda expression in the first invocation of and then is a function that takes a string and returns a string. The second takes a string and returns a string array. I'll run this now. You can see my name is all in caps, but with my last name listed first with a comma, then my first name. Let's just try one more. I'll again copy 3 statements, the first 3 of the previous function. I'll rename F1 to F2 and change the return type to be an integer. Actually, I didn't want to copy the last and then call, so I'll delete that one. But then I'll add 2 more chained calls with different lambda expressions. The first lambda will join a string array into a string, delimited by a comma followed by a space. The second is a method reference that returns the length of the input string. I'll print the result of this chain of functionality. Look at the IntelliJ hints, specifically the second type argument of each inferred function. You can see it goes from a string to a string array and back to a string in the hints shown here. But the ultimate return type is integer, which is how I set up the declaration. Again, it doesn't matter what the parameters or return types are in the interim expressions, as long as the one chaining to the other is passing the expected data. Running that now. I get the length of my name 13. You can imagine that for the last challenge video, instead of cycling through a list of functions, you could write co-chaining functions like this. Okay, so those are the 2 convenience methods provided to us on the function interface. The and then method is also available on the by function and binary operator, but not for any interfaces that have a primitive argument like int function, double function, or long function. The consumer and by consumer interfaces, as well as the primitive versions of consumer, also have an and then method. Remember, a consumer doesn't return any data, so whatever the input is at the start of the chain will remain the input for any following chained expressions. I'll set up a string array of a couple of names, Anne, Bob, and Carol. Next, I want 2 consumer variables, assigning one a lambda expression and one a method reference. This lambda prints the first character of a string. This method reference is a call to the println method on system.out. The first expression will print the first letter of the name. The second expression prints the entire name with a new line. In this case, nothing will get returned from these methods, and therefore s is always the value of the parameter passed to the consumer functional method. I'll add some code to loop through the names and execute a chain of and then methods. The lambda expression I'm passing to the for each is a compound statement with multiple and then calls chained together. If I run this now, I get the first initial of each name printed from the S0 lambda, a hyphen from the lambda passed to the first call of the and then method, and then the full name, which is the result of the S1 variable being passed to the last and then call. Pretty cool. If you had a series of methods with void return types, you could imagine chaining them this way, executing a variety of different methods on an array of strings like this. Okay, I want to look at the convenience methods on predicate. These are completely different because predicate returns a Boolean value. They methods allow you to create compound test expressions that evaluate to a single Boolean value. The names of these 3 methods are 1, negate, 2, and 3, or. To try these out, I'll set up 4 predicate variables, each with a different lambda expression. This lambda tests if the input string equals Tim, all in caps. This one checks if the input string equals Tim, ignoring case. This checks if the string starts with T. Finally, this 4th lambda will be true if the string ends in an E. Now, I want to set up a combined predicate using the OR method, and I can do this by calling that method on one predicate variable and passing it another. I'll call this new variable combined one and assign it p1 dot or passing p2 and print it out. Here, this code will test if either of the predicates p1 or p2 is true and return true if either is true. Running this code now, I get combined 1 is true when I test it against my name in mixed case. This tests true on the p2 predicate, which tests equality with equals ignore case. Okay, now I want to test the AND method with the p3 and p4 variables. I'll set up another predicate variable calling it combine2 and assigning that p3 dot and passing p4, and I'll print the result. This code tests if the string starts with T and if it also ends with E. I'll run it. I get combine2 equals false because Tim doesn't end with an E. What if now I wanted the opposite result of a test? To solve that, I can simply chain a call to the negate method. My next variable, combine3, will do what combine2 did, but additionally chain negate to it. Negate takes no parameters and simply returns the opposite result of the result from the previous functions, and print out the result. Let's confirm that works as expected. I get the opposite value of combine2 with the output combine3 equals true, so that might be useful down the road. Predicates are going to be used a lot more when we get to streams, but it could be useful in other situations. For example, the remove if method on lists might be a good candidate. This feels like a good place to stop this video. In the next video, I'll be revisiting the comparator. I think you have a pretty good understanding of how this interface works, but this one too has helper methods, some of which I haven't yet reviewed, and which are going to be very convenient in future coding samples. I'll see you in that next video.